So if you're getting serious about water chemistry, here's what you need to know. We've already done our pH, so we'll slide this sample into the OctaSlide, and then we'll kind of hold this up to the light, and we should be able to read, based on our color, what the pH is approximately. So right here, it looks pretty green, and it's probably somewhere between pH 7.0 and 7.5. So if it's somewhere in between, we average those numbers, and I'll call it 7.3, and we can record that number. Now, our dissolved oxygen, we will measure with our oxygen probe because we have one. If you don't have one, this kit comes with a Winkler method for testing dissolved oxygen, and you can follow the instructions to do that yourself. We've had the most time for our nitrite to set up, so I will go ahead and invert this a little bit again. And you see there's a slight pink color to the background, so that means there's just a little bit in there. I'm going to go ahead and remove my pH sample from here, as well as the pH OctaSlide, and then I'm going to add the NITRITE OctaSlide in there. So you can see those are different colors. So you can add this into here and then place the sample in next to it. So you can see there's different colors, and then the different colors correspond to different concentrations in the water. So because our color is lighter than what we see here at the bottom, we want to slide this up and hold it up to the light. So you can see the water color compared to the OctaSlide reading is less than the bottom of the scale. So we're reading at 0.05 milligrams per liter. So this number I'm going to go ahead and record. Nitrite at 0.05 milligrams per liter. That's really good. We want to be as low as possible on nitrite. The next test we'll look at is going to be ammonia. Our ammonia's been setting up for 5 minutes now. So we'll go ahead and add our OctaSlide into here for ammonia. And we can see the colors are very light in here. So you want to compare the color of the sample to the numbers on the side. And we're looking at probably 0.4 to 0.2 milligrams per liter. So I'll record that as 0.3 milligrams per liter. Okay, and our next sample, our next test that we're looking at is going to be our nitrate. So we've now waited 10 minutes for this one to set up. So we'll add our nitrate. OctaSlide set into the comparing, and now you can see we've got some colors set up here, and we're going to try to compare those colors to figure out what the number is going to be. So to me, this looks like it's between 2.0 and 4.0, so I'm going to record this number as 3.0 milligrams per liter of nitrate. One of the next tests we're going to do is we're going to do iron. So we're going to follow these instructions. We'll add 0.2 or 2 milliliters of our sample into our testing tube for iron. So we already have our reagents here, and once we mix this up, put our cap on, we wait 15 minutes for the numbers to set up so we can read our iron levels in the water. I have a disposable pipetter here, and this is a 1 milliliter pipetter, so I'll take my sample up to here and do it twice and add that into my container. So I have to take my lid off. Squeeze the bulb and then draw that water up into the pipetter. We've got 1 milliliter. Okay, and then we'll do this one more time to get 2 milliliters of water sample. Try not to get bubbles in here, as that will make your reading off a little bit. So, following our instructions over here, now we have 2 milliliters of sample. Then we need to put the cap back on, put that rubber stopper back in there, and we need to invert it 2 to 3 times. And then we wait 15 minutes for this to set up. So I'm going to put this back in my rack right here. So now in the meantime, I've got a little bit more time. I'm going to go ahead and do alkalinity. So the test for alkalinity requires these components here. So if we read our instructions for alkalinity, we're looking here at adding 5 milliliters of sample into the larger container. So I will take my sample water, and looking on the side of this cylinder, our test tube, we're going to fill up to the 5 milliliter mark. Okay, we have 5 milliliters of sample here. The next step is to add 4 drops of the blue-green methyl red indicator. So I take the cap off. It's going to make the water turn colors. 1, 3, 4. Okay, then we'll replace the cap. And these samples come with caps here, like so. You add this cap onto the top to help you swirl and do the titration. So I can go ahead and place this cap on here. And then the next step, I'm going to use my, this is our titrator. So basically this little syringe has some numbers on here that you can see. It goes up to 200. And so what I'll do is I will take this syringe and our alkalinity titration reagent here, have a little hole in the top. I can press my syringe in there, turn it upside down, and then I'll go ahead and start extracting some sample. If you get an air bubble in there, make sure you're using only one of these syringes so you don't contaminate your sample. I've been using the same one the whole time. So I can push this back and get the air bubbles out of that line. Now I can start extracting sample through here, or extracting my reagent. So I want to go all the way down until the plunger is at the 0 mark. Now I'll turn this all back over. Now I'll take and put my syringe into the lid here, and what I'm waiting for is for the water color to change. So I'll add a little bit of my reagent here, and you see how it turned pink a little bit. Our goal is for the whole sample to turn that pink color. So add a little bit at a time and swirl, a little bit more at a time, swirl. You see, keep adding until the water color changes. So now we see that we've changed from a green color to that sort of a pinky red color. And so what we'll do now is we'll read on here what the alkalinity level in terms of milligrams per liter. So 60 milligrams per liter is what we're reading here now. I'll record our alkalinity levels at 60 milligrams per liter. Our goal is to have an alkalinity less than 100 milligrams per liter, but more than 40 milligrams per liter. So we're in a good range right now. So now it's time to read our iron, and you can see that our color has started to set up here. So this is a test tube that we're able to put into our spectrophotometer here, and this is going to read the concentration of iron. So we'll go ahead and wipe this off so that we get a nice clean reading, and we'll put it inside of our machine, and it's going to read off what the sample is, and then it's going to give us a concentration. So we're looking at 0.955 milligrams per liter of iron, and so our goal is to have 2 milligrams per liter of iron. So we're going to add a little bit more iron to our water in order to make sure our plants are good and healthy. Now that we've measured the water parameters that we're looking for and we've recorded those, we can monitor them through time and make sure that we have healthy water for our fish and plants. If you do these things, you can be successful in aquaponics too. So your goal is to strike a balance between the fish waste being produced and the plant uptake of those nutrients. If you have more plants than you have fish waste, your plants are going to become stunted.